Good morning, everybody. We have just started the webinar, so we'll take a few seconds for people to actually join in before we kick this off. Thank you for joining today. So together with Ben Finsel, we're going to talk about the AMD launch and the Dell launch together with AMD about the servers and the CPUs that we're bringing to market. It's a session that we're going to do will take about 60 minutes or so. As I said earlier, we're going to wait a couple of seconds before we kick this off for people to actually be able to join in and join the stream. The first part of the webinar will be Ben talking about the new AMD CPU launches and the technology coming in. And then the last portion will be me talking about the Dell portfolio that we will have at AMD that we will bring to market. I think we have waited around a minute, Ben, so I would say that I'm going to shut up and give you the floor for now and take it away.
Thank you very much, Martin. So my name is Ben Finstel, or complete legal would be Benjamin Finstel. I'm in charge of Dell Technologies from an AMD side. So my only customer I'm handling is basically Dell. And with this, I would like to kick it off with a small intro video into the session. And with this, let's move on into basically a little bit of the past and also into the, nowadays. So when we joined back in the data center back in 2017 with the Dell 14th generation, AMD had astonishing 2% of market share, right? But shortly after, we already introduced our Rome CPU, which was a second generation, and Dell in this case also decided to do a new generation of servers. And shortly after that, we were already at 8% of market share. So we already, multiple times added more market share to it. And even with the next generation, which was a drop-in, which Milan was, we even grew our market share even further until 27%. And back in 2023, we introduced with the 16th generation together with Dell, our Genoa and Bergamo CPUs, and were able to increase this even further, that we ended 2023 with astonishing 31% of market share. And mid of 2024, after the first half year, we ended up at 34% of market share. And the best point about this one is that the first 4 generations, and as well as the 5th generation, Turin, which is now available with Dell together, was basically executed on time, which means there was no delays at any point. So we have a reliable roadmap. And even in the future, we are going to stay with basically Italian cities, but there is already a 6th generation and even a 7th generation on the horizon to be seen. So we will keep our journey with the EPYC within Italy. But what did we achieve basically with the 5th generation, or with over 5 generations of CPU leadership? On the left side, as you can see, we have basically the core count times 6. So in the first generation, we only had 32 cores maximum. With the now available Turing CPUs, we have basically a maximum of 192 cores available. So which means there is a massive lot of increasement. But on the other side, we didn't only increase the core count, but also we nearly close to 11 times increased the performance over those generations. So which means we not only increased our core count from generation to generation, but also we increase the performance levels on those CPUs, which means we have a great benefit in most of the areas. And so, but how Turin is looking like? Basically, Turin is basically divided in two different kind of flavors, okay? So the first flavor is on the left side, which is scale up, which does have a maximum of 16 CCDs, Zen 5 CCDs to be precise, and a maximum of 128 cores, so 256 threads. And the other side on the right is basically the scale out option, which uses the Zen 5C cores with a maximum of up to 12 CCDs per CPU. But the core complex is increasing the core amounts, which means we have the options to scale up to 192 cores per CPU. So, but the best benefit is, because we have decided to go that way, is that the chiplet technology is basically optimized for this kind of approach. So we are able to increase the core counts like desired, as well as moving over to different kind of CCD. So, and from an AMD perspective, we are the industry leader in the chiplet technology for both sides, right? So, but if you go a little bit more into detail, okay, so the most benefits is that because of the centralized I/O die, the instruction sets and everything across the scale up, so Zen 5 to scale out with Zen 5C, is basically exactly the same. So there is nothing different, right? So on the other side is the scale up version is optimized for the highest performance, while the scale out workloads is basically optimized for the highest core density per socket. So you can mix and match them if required. So as I already said, the I/O die is exactly the same on both ends, but also AMD decided to move down from the previous generation with the starting core counts, because with Genoa the starting point was 16 cores, and with Turin now it's basically 8, which means we have the options also for smaller environments to literally position 8 core CPUs to avoid anything missing at the bottom, right? So if you now go a little bit into the manufacturing side of things, okay, so the scale up version is basically manufactured on a 4 nanometer lithography from TSMC, while the Zen 5C is basically produced at 3 nanometers, right? The main difference is that the classical Zen 5 versus the Zen 5C has maximum of 8 cores with 32 megabyte level 3 cache, while on the other side, the scale-out version does have 16 cores with a maximum of 32 megabyte level 3 cache. So that is basically the most difference. But if we move now a little bit further and look what happened from generation 4 to generation 5, as you can directly see, there is basically an IPC uplift available directly on average on roughly 17% if you're looking into classical enterprise and cloud server workloads, right? On the other side note, if we move over to the HPC and AI stuff, and most of the times today we are already, most of the customers are interested in AI and HPC nowadays, there is even an increase on 37%. So this uplift with 37% is the reason because AMD decided to adopt AVX 512 with a full 512-bit data path to ensure that everything is moving faster along stream. And this is enabling customers around the globe to be even more efficient when it comes to HPC and AI workloads, right? So that is basically how we achieved it. So on the other side, in the middle of the slide, you basically are able to directly see in which areas we improved the most. So that is basically the breakdown for the 17 and the 37%. So if we are now moving a little bit forward, and that's basically now we are looking into the CPU stack available from AMD together with Dell. So on the left side of that slide, as you can see, basically we have the core density, which has massively increased. The energy efficiency is still our main focus area. And because we decided to bring in new CPUs like the 8-core CPUs, the OPN or the CPU stack increased a little bit. So from that point of view, as you can see, we have all kind of flavors from smallest to the biggest core counts, and we are also able to maintain even CPUs with a small energy requirement up to CPUs which can consume 500 watts without any kind of problems. So, and even with the high frequency paths, we are able to maintain a lot of base frequency, especially in virtualization environments. Those FCPUs with the changed licensing are getting more and more interested. interesting. I'm going to show you later on a little bit around this kind of slides. So, but the biggest challenges customer around the globe are three main pillars which are faced, right? The first thing is the modernizing of the data center with AI, and for obvious reasons also for AI. So the problem is that the budget is most of the times tight. The physical and also the power limits for the data centers are basically hit or already exceeded, right? And with this, we are moving over to the disruption of the VMware licensing cost due to the acquisition of VMware customers from VMware with a complete new licensing model and increased massively the licensing costs around the globe for most of the customers. On the other side, we have the corporate sustainability moving more and more into the future or into the focus point for many, many customers. So more than half of the world's largest companies have committed to basically net zero goals and so on and so forth. On the other side, everybody in Europe received most of the times an increased electrical cost, like also in California, or in my case, I'm from Germany. In some certain areas, I needed to pay twice or sometimes even three times the energy costs than the year before. So that is basically something which is basically driving more and more the customer into the focus points. So, and that with this, we are happy that we can collaborate with Dell in this kind of view. So we have basically the option with AMD CPUs together with Dell to basically drive a server consolidation in the front. So, and yes, the average data center in the world is around 100,000 square feet big, but to be fair with you, 100,000 square feet translates over to 10,000 square meters. So, but this is not always intended for the most for those big data centers. It's basically intended from a small server cabinet over to a small server room up to the biggest data centers ever. So it's not only intended for the biggest ones, but what all of those data centers or server rooms share is basically that most of the space and for power consumption as well is dedicated to old and inefficient hardware and even hardware which is hard to sometimes even not able to be managed. So, and even for the North America side, the data center capacity is down to less than 3%. And this does not only mean physical space, but also electrical energy. So there are problems to get enough energy into the data centers to feed the requirement for the future. So, and what do you achieve if you're going to consolidate the workloads? So basically, if you are consolidating 5-year-old hardware from our competition, then you are able to basically reduce the space requirements by close to 80%. Right? On the other side, if you're going to reduce the physical space, also the power limits or the power requirements is dropping by close to 75%. But on the other side, if you have less requirements for hardware, right, your IT stuff basically gets time back because the TCO, the total cost of ownership, is basically going to decrease by around 50%, sometimes even more. And this kind of savings, space, energy, and also manpower, you can reinvest into basically, yeah, AI. So the IT stuff can invest or focus on AI where they can use AI, and even the data centers or the rack servers and rooms do have finally enough power again to power future environments. So, and if you are basically going over to how we are doing this, so basically this is an older slide. Unfortunately, I was not able to get a new one for Turin. But if you are taking a look onto the legacy competition core, the typical physical to virtual core ratio is 1:3. So one physical core can maximum handle 3 virtual cores. On the other side, even with the newer generations, it's basically the ratio is only changing from 1 physical core up to 4 virtual CPUs. With our high frequency parts, and as you remember some slides ago, I was basically talking about those kind of high frequency parts, we are basically able to maintain up to 6 virtual CPUs per physical core, even on the Genoa parts. And now with Turin, we are even able to increase those core requirements or those physical to virtual CPUs by 1 to 8. So you can even have nowadays one core handling 8 vCPUs. And this enables you to basically drop down the pricing of the licensing cost, because if you're able to maintain more virtual CPUs per core, you're able to basically save licensing in the future. I have an example with me with Genoa in this case. So if you're going to do basically a consolidation in this case of 10,000 VMware points, right? On the left side, you would require 38 servers with the from the competition with 32 core CPUs. On the other side, if we would move over to AMD with 48 core servers, then we would drop that amount by 21 servers. And this is not only, you're not only dropping the servers, but we are also dropping down the required cores with this in correlation. The licensing is basically dropping down in this case by up to 40%, right? On the other side, less systems consume less power. So we are reducing basically the power requirements and the power cost over time. And this is basically not only for the CPUs or the servers itself, but also for the data center and for the cooling from the air conditioning. On the other side, this is only an example, and every customer needs to be basically looked at individually to get basically the sweet spots. But we are not only actively in the CPU space, but also in the AI space, right? And you can basically use AI also on our EPYC CPUs. So we have software stacks available called ZenDNN to enable you. From another perspective, and as you can see, we have basically a strong roadmap even in the future for our GPUs. 2023, we announced basically is the MI300X, right? So on the other side, last year we announced the MI325X already, and 2025 there will be a new series coming around, which will be the MI350, and even within 2026 we are going to have a newer version, which is the MI400. So that is basically the point. There is a lot of traction in the movement around AI. But if you're taking a look into the bigger accelerators right now nowadays, with the MI300X, we receive compared to the competition up to 2.4 times higher HBM density per card, and even for an 8-way UBB. And on the other side, we have roughly 60% higher bandwidth compared to our competition. But as we're talking about hardware is not everything. You need also to have the software to basically actively run everything. So, and compared to our competition in this kind of space, we have committed completely to open source software. So we don't have anything behind closed doors. So and we are partnering in this case together with Hugging Face, and Hugging Face has right now 1.5 million models directly available, which will run out of the box directly on our hardware. So on the other side, we are not only working on everything to get everything ported over to us, but we are in the movement to get basically together with PyTorch, TensorFlow, and others to get away from the port 2 option to customers and software engineers to develop on our latest platforms together with Dell. Otherwise, we are not only working together with Hugging Face, PyTorch, TensorFlow, but also, for example, with OpenAI together to enable customers also using Triton to be effectively working everything. So, and if we are basically moving a little bit forward, right? So Dell offers you the so-called AI factory, and we are heavily proud to be finally able to join that AI factory together with Dell to enable customers finding options and solutions together with AMD hardware in the bottom. And the best thing is it's basically simple from the end, from Dell, from the customer to Dell. It's basically tailored solution, and it's basically a trusted environment. So, but what can you achieve if you're moving over to AMD GPUs, right? So on the AMD GPU side, so typically one GPU can handle one LLM, for example. In our case, we are able to have with 8 cards, 8 instances per model. But on the other side, moving something in is just the first step, right? You need to optimize everything behind it to fine-tune to receive the highest possible performance for your use cases. And on the other side, 8 models nowadays are not the end, because we can do a partitioning of our cards with 8 partitions per card, which enables you, depending on the models you are running, to have up to 64 models in a single box. And with this, I'm happy to move over to the newer generations of AMD service, and more than Martin will talk later on this kind of behalf a little bit more. So on the other side, we have our classical 1U systems with 1 and 2 sockets, as well the same with 2 height units with 1 and 2 sockets. Those CPUs compared, if you compare them with on the efficiency side, we have a higher performance per core up to 37%, right? Which means they are purpose-built and equivalently developed. On the other side, like I showed you in the past already, and with a couple of slides ago, we have an extreme high consolidation rate. So sometimes even up to 7.1 of a consolidation, which means we have 65 up to 65% lower CPU energy cost, and also with this lower system-based things. On the other side, we all know we are going to be attacked more and more because there is cyber warfare going on. So which means we increased our security processor to 256 encryption. But this is not everything. Okay, so we have basically also for the first time ever with Dell together an XE7745, which is designed to host up to 8 double-wide GPUs or 16 single-wide GPUs in a 4-height unit system. Otherwise, because this is a complete Turing-based system to enable you as customers to have a good CPU performance to GPU ratio, you are able to get into this kind of system up to 192 cores. So the biggest CPUs we have is Turing. And also on the other side, with a cyber resilient approach again, right? But as you can see, we are going to extend this kind of portfolio even further. And with this, we are happy to have with Dell together an open compute platform rack with 21-inch, which is enabled to help you in HPC environments to ensure you have the most cores per rack space. But more on this kind of with Martin. So, and with this slide shows you simply an overview. On the left side, you see the platforms, or the basically bare bones servers. Let's say it this way. And we have basically here not only basically the current generation displayed, but also the older generation, which is still available with Dell. So you have now the 16th generation and the 17th generation with 1 and 2 height units available without any problems. Then you have also on the other side node in the top, the GPU-based systems, which basically are designed for AI inferencing and training. And on the other side, with the M7725 and the C6615, also relatively chassis solutions to enable you. On the other side, as the servers are only the base for everything else, we are happy to have with Dell together Vison Ready nodes, Rail systems, Nutanix, PowerFlex, and so on and so forth to enable you to select the right approach for everything. So, and if we are going to move a little bit further, so AMD together with Dell is basically the perfect fit, right? So in future scenarios, we are going to see an even higher increase on demand on compute performance. It might be on the CPU, but it might also be on the GPU. On the other side is you need to reinvent your data center and do a consolidation and review of your equipment to have the AI innovations in place nowadays. And since CES this year, we have together with Dell the broadest AI portfolio existing, because AMD and Dell do share now also clients. So you can use AI not only in the data center space on EPYC CPUs or Instinct GPUs, but also nowadays on Ryzen CPUs. So, and with this, Martin, I would be fine, and I would hand over to you.
Yeah, thank you very much. I am going to start sharing my screen so that I can show my slides. Thank you very much, Ben, for this for all of that insight on the new technologies from AMD coming in. So what I'll go into the second half of this webinar is go into a little bit more depth about what Dell also brings to the table combined with the AMD technologies. So looking at that, one of the things that we see is that we are currently in a time where we have unmatched opportunities, but also unprecedented challenges. I can't remember a time in IT that there was such a buzz going on about what's happening. So the whole AI and the Gen AI race that's currently happening really has an impact on all of our customers, and I'm assuming the listeners at home as well. So all of the, let's say, standard challenges that most customers already had in the past, like multi-cloud adoption, how to enforce zero trust, how do we do sustainability, all of those are compounded by the AI race that's currently happening and makes it very hard for customers to adopt and be able to surmount all of those challenges. Good thing to know is that with Dell PowerEdge, we can help you accelerate that transformation anywhere. So we can help you in that IT transformation. And one of the key things to remember there is that Dell servers, Dell PowerEdge servers are built around three key tenets, and that's the purpose-built, intelligent, and cyber resilient. So when we look at purpose-built, what we mean with that is that, for instance, we build all sorts of different platforms for different types of workloads or for different deployment locations. So we obviously have, for instance, the XR series, which are designed to be able to run outside of a traditional data center. So they have their own air filtration. They have extended temperature ranges in which they can operate. They have additional physical securities because, again, they run outside of a typical data center. So they can be deployed in anything from, let's say, a remote branch office to a telco RAN tower to anything that you can think of that is not sitting inside of a typical data center. Obviously, the R series is our, let's say, bread and butter server. This is the mainstream workhorse that you would deploy typically in a data center that would be used for virtualization or for any type of workload just requiring a normal traditional rack mount servers. What we saw in the past was that in those R servers, we could also deploy a lot of GPUs in there to be able to do either AI or to do VDI solutions or anything that would require a GPU acceleration. What we have seen happening in the last few years is that because of the TDP rise of all the different components, that it is getting very hard for us to still have a lot of GPUs in a simple R series. So we still have them, but we're also focusing on dedicated platforms that are designed to be able to handle a GPU acceleration. And that's the XE series, so the extreme acceleration. And there we have systems that are either air-cooled or liquid-cooled and are really specifically designed to be able to handle a very high-powered GPUs in there. Lastly, obviously, we also have the T series, which can be deployed pretty much anywhere. They have reduced acoustics so that you can actually have them in your office under your desk without having any issues with that. Another key factor for purpose-built is the platforms that are designed for maximum efficiency. So I'm going to be blunt, an AMD CPU from a specific SKU will have a certain type of TDP, and it doesn't really matter if you buy that through us or through a competitor of us. It's the same CPU, it will have the same consumption. So what we as Dell can actually do to make a difference and to make sure that our systems are as energy efficient as possible is that we take all of those different things that you see here, like chassis flow optimization, efficient fan technology, so that we have an efficient system airflow, which reduces the power because all the power that we use just to spin the fans is wasted power. So anything that we can do to reduce the RPMs of the fans will actually, in the end, be a more power efficient server. And then on the middle row, you have things like component placement in the system architecture. So where do we place the network cards and the GPUs and the power supplies so that we can actually have the best optimal airflow through a system? We have local airflow management. So we work with ducts and shrouds to make sure that we channel the airflow where we want that to be, as well as advanced cooling technologies that we add in there so that we have an optimized hardware design for component cooling. All of those things together make sure that we have an as efficient as possible solution that will give you as a customer a better TCO. The intelligent pillar really comes down to our systems management capability. So that's where we do things like manage with clarity, where we have a unified dashboard, which is a single management interface and your view into your IT infrastructure, where we can do automated workflows for streamlined deployments and updates and configuration and automation. We can manage any environment because in the end, every Dell PowerEdge server has an iDRAC, and because it has an iDRAC, it can be managed in the exact same shape, way, and form. So any Dell server anywhere, if it's a rack, a tower, a modular data center, if it's an extreme acceleration, doesn't matter. We can manage it through our systems management tools. The other key component there is that we are powered by Redfish. So we're leveraging industry open standards that are secure, scalable, to be able to do our automated Dell server management. And then the last there is the monitoring that matters. So we have things like proactive alerts that are AI-driven insights that you will get you will get notifications before anything actually happens. So when we see that, for instance, a DIMM is failing or a fan is failing or whatever it might be, we already give you warnings proactively so that you can replace something before it actually breaks down. The other thing is obviously the comprehensive system health. So we ensure that security, firmware compliance, energy efficiency, we can do real-time monitoring of the hardware, the power, and the thermal performance, all again through those single panes of glass. So that means that at the box, we have the iDRAC. Then the element manager on-premise would be Open Managed Enterprise. And then if you want to, you can even extend that with our Apex AIOps, which is a SaaS offering that Dell has. So all of these tied together so to give you as an end customer full management capabilities from a single server to multiple servers in the Open Managed Enterprise into an aggregated overview in your Apex AIOps. Last but certainly not least is the cyber resilient pillar. And all of that starts with the silicon root of trust, which I'll explain in a little bit more detail in the next slide. So obviously we adhere to the NIST cybersecurity guidelines of the protect, detect, recover. And for everything that we do in our development, either it being physical hardware development or it being software development, we follow the security development lifecycle to make sure that we adhere to that and make sure that there are no problems that arise during the design of our systems. We obviously have end-to-end supply chain assurances, which we can also extend with our secure component verification, which I'll go into a little bit more detail. And our security extends into the entire server ecosystem. A key thing to note there is that also for Dell security is physically built in. It is not bolted onto the server. So it's an intrinsic foundation of the server itself. So when we look at the protect phase of the NIST cybersecurity guidelines, as I said before, it starts with that silicon root of trust. So what that means is that every Dell server on the system board has an immutable chip that holds the public keys to the Dell certificate. What that actually does is when you power a Dell server, so when you physically cable it up, the first thing that wants to happen is that the iDRAC wants to boot up so that it can start managing and monitoring the server. For it to start up, it first needs to go through that silicon root of trust. And then during that, when it goes through that, the silicon root of trust will actually verify to see if the Dell is running Dell validated code based on that certificate. If it is not, we will not allow the iDRAC to boot, and it's actually cut off through that silicon root of trust. If it is running Dell validated code, we know for a fact that the iDRAC is secure. And from that point onwards, we can load the entire firmware stack. Every firmware coming in that you do an update, like a BIOS or a storage controller or a drive or a network card or whatever it might be, will also have obviously certificates from Dell. So anytime you install an update, the iDRAC will first check to make sure that the code you're installing is actually Dell validated code. If it is, it will allow the component to be updated. So that way we know for a fact that the entire stack from iDRAC all the way to all of the firmware components are all running Dell validated code. The other thing that we also do with that silicon root of trust is that we also verify the BIOS domain. So during the BIOS boot, the BIOS will actually go through that silicon root of trust. We'll verify that the BIOS is also running Dell validated code. If so, we'll allow the BIOS to boot, the UEFI stack to load, and from there on out, we can actually also use the AMD secure code processor to do the entire boot stack validation. So from the BIOS to the UEFI to the bootloaders to the OS being loaded on with secure boot, everything, that entire stack is also validated and secured. Another unique Dell feature is that we have the ability to do enhanced secure boot. So what that means is that instead of leveraging secure boot with the industry standard certificates that are available, you as an end customer can actually sign your own certificates into the operating system and into the UEFI boot to make sure that only your signed OS is able to load, or hypervisor is able to load on that Dell server. So that's another additional security feature on top of that. We can also do data encryption at rest. We have secure enterprise key manager that resides in the iDRAC, where we can actually do data encryption on self-encrypting drives, either with local key management or either handing off the keys to an enterprise key manager. The end-to-end secure supply chain. So one of the things that we do there is a secure component verification. So what that means is when you order a Dell server from the factory, you can actually get a secure component verification, which means that we'll cryptographically create a hash of all the components and their IDs and burn that into the TPM, into the iDRAC. We'll ship the server to you, and then we'll send the secure component verification into the Dell digital locker towards you, so that when the server arrives, you can actually run a utility to check if the server that we have sent is also the server that you have received, so that there was no meddling in between and nobody added or removed any of the components. In the detect phase, we have things obviously like audit logging, secure alerting. We have firmware verification, which I already mentioned with the Silicon Root of Trust. We have chassis intrusion detection, and we have drift and change detection, which is a combination that we do with, for instance, Open Managed Enterprise. So what we mean with that is in OME, in Open Managed Enterprise, you can set up compliance templates that tell the desired state for the configuration that you have. So you can put in BIOS settings, iDRAC settings, network settings, any setting that you have in a Dell server. And then you can start checking groups of servers to see if they are adhering to the templates that you've specified. And then if somebody actually goes in and accidentally changes, for instance, a BIOS setting, or even worse, with malicious intent changes a BIOS setting, you will actually get an alert in Open Managed Enterprise, see what has drifted. So you will see the expected value, the current value. You can hit the checkbox and say remediate, and we'll just push those settings back the way that they need to be. In the recovery phase, we have the BIOS and OS recovery. So basically, we have a redundant BIOS. So even when during a BIOS update, you pull the cables from it, the power cables, we can still go back to the last known good state to be able to boot the system up. We have easy restore. So actually in the bezel of the server, in the rack area, there's a small flash storage device that will hold the most critical information for a Dell server. So things like the service tag, MAC addresses, and stuff like that. So that when something breaks and a Dell technician needs to replace the entire system board, we'll actually restore all those values automatically for you. The last one there, the rapid system erase, is the function where you can cryptographically erase an entire Dell server in a matter of time that it takes to boot a Dell server. So what we do there is when you initiate that, we'll actually do a factory reset of the BIOS and the iDRAC and the storage controller and stuff like that. But we'll also cryptographically wipe all of the drives inside of the server by leveraging the instant scramble erase feature, which is an industry standard that all Dell drives have that we sell. So looking at a little bit more in detail about the servers that we have been launching and have launched with together with AMD. It is pretty much a continuation from at least in this slide in what we had in previous generations. So looking at the single socket, we have the R6715 and the 7715, which is a 1 and 2U single socket AMD system. There we will go up to 160 core AMD EPYC 9005s. And one of the neat things there is that we now have the capabilities to go to 2 DIMMs per channel. So that means that we can have up to 24 DIMMs in a single socket AMD model, which really gives you the opportunity to do workload consolidation on a single socket system, allowing you, depending on the workload, obviously, to maybe have a better TCO. From a drive perspective, both the 1 and the 2U will have multiple drive offerings. From 2.5 to 3 E3S drives that we have, so that those are the NVMe drives. And then depending on the configuration and the chassis configuration, we'll also be able to add a number of GPUs in those systems as well still. In the dual socket space, it's pretty much, again, the 1 and the 2U, but then in the dual socket, so the 6725 and the 7725. And these are also the systems that go up to the full 192 core count that AMD offers in their EPYC 9005. We would be able to go to 2 DIMMs per channel here, albeit it that in a 19-inch rack, you only have 19-inch space. And if you have 2 CPUs, we cannot physically accommodate 48 DIMMs in a single 19-inch rack width. So there we only have 1 DIMM per channel. So you still have up to 24 DIMMs max capacity in those systems, which is the same as a single socket. One other neat thing about the dual socket though is that because it's one DIMM per channel, we have the opportunity there to go up to the 6,400 megatransactions bandwidth for the memory bandwidth. Also, both the 1 and the 2U will have multiple different drive offerings. And obviously, all the PCIe lanes, both in the 1 and 2U dual and single socket, will be PCIe Gen 5, will have OCP card configuration. And then again, as I said, with the single socket, depending on the configuration that you choose, there might still be room for GPUs. Another neat thing that comes with those new AMD CPUs is that they now also support CXL 2.0. So a little later on, we will actually have CXL memory adding cards that will allow customers to be able to extend the memory pool that they have, either to make sure that they have the maximum bandwidth available to the memory, or to be able to extend the memory pool using let's say price per gigabyte optimized DIMM. So right now, the most cost-effective DIMM capacities are either 64 gig or the 96 gig DIMMs. And with CXL 2.0 memory expansion cards, you could populate, let's say, 96 gig DIMMs in your server. But then if you still need more memory space available, you can actually extend that using those CXL cards with more 96 gig DIMMs in there, which is very cost effective. The majority of these systems are already live right now, but they're still at limited configuration during this launch. Near the end of this month, we will have full configurability of the majority of those platforms. And then in June, everything will be fully configurable and available. So one thing that Ben already mentioned was the M7725 PowerEdge. So this is, let's say, the future of high performance computing. So this is the next level HPC. This is the next level high density computing. So this is based indeed on an OCP v3 rack. So that's a 21-inch rack width. And with that comes its power and its cooling. So it's direct liquid cooled. We can do up to 10 kilowatt cooling per height unit in that rack. We can go up to 460 kilowatts per rack in the future. So it's designed to have very high density. In the rack that you see right here, it's somewhere along the lines of 120-ish kilowatts per rack. But just to give you an idea, there are going to be 72 nodes inside of one of those racks. And each height unit already contains 2 chassis, so 2 compute nodes. And each compute node has 2 sockets. And each of those sockets has 192 physical cores. So when you populate this rack fully, you're talking about 27,000 physical cores per rack. That is pretty high dense compute. I'm also in the understanding that for the majority of this of our customers, this will be either too big or too power hungry, let's say. But it's really cool to see where the industry is moving. The other one that Ben already mentioned was also the XE7745. So what this is a 4U dual socket AMD machine based on EPYC 9005, where we can have up to 8 double wide GPUs in there, up to 600 watts per GPU. And we can even do using NVLink, for instance, or any bridge for a GPU card that's a double wide card to bridge those cards together. We'll have up to 8 PCIe Gen 5 slots in there, 1 OCP slot to be able to do that, and up to 24 DIMMs there. But the nice thing about this is that it's still an air-cooled server. So it can go in any normal air-cooled data center and will consume somewhere between, well, 5 and let's say 10 kilowatts. But that's dependent on the configuration that you put into the server. It also has an equivalent, by the way, for the competitor to AMD, which I'll not name out of respect to Ben right now. So the last thing I actually wanted to highlight is that during the launch of our next gen AMD systems, there are currently smart deals available for AMD on the current gen that we have. So the 6725, 7615 and the 6625 and the 6615. And those are available from the 5th of March until the 2nd of May. So please contact your Dell representative or look at the Dell.com website to see those smart selections based on the 16th generation of Dell PowerEdge servers together with AMD. That was actually the last slide that I had and wanted to go into. I don't know if there were any questions still coming in from the viewers that we have or participants in the webinar. I'm looking at another screen right now and I don't see any questions coming in so far. So with that, I'll give you back about 15 minutes of your day so you can have an early lunch. Thank you very much for joining. If there are any questions, please reach out to your Dell representative or to an AMD representative. We're always more than happy to help you. Thank you for your time today, and I wish you a very good day, and until the next time.